If you're working with Unreal DMX, you probably wondered, can I use custom Gobos on these lights? The short answer, yes. The honest answer, there are 3 different techniques I like to use, and only one of them is a little masochistic. I'll show you 3 use cases and you can pick the most practical solution for you. These go up in complexity, so learn what you can and bail if you fail. I made a rhyme. I'm Ryan. I'm a professional lighting designer and a virtual production enthusiast working across TV, film, adverts, and live events. Enough about me, let's dig in. I'm using Unreal 5.7, but this workflow applies to most Unreal 5 versions. I strongly recommend starting with the Unreal DMX template. It saves time and avoids plugin and settings pain. For this tutorial, I'll be playing with a Robin Pointy and its available Gobos. Head over to GDTF Share and download the GDTF file for the Pointy. If you haven't been here and feel lost, I have a tutorial on this in my Unreal DMX tutorial series. I'm about to show you something really cool. Place your GDTF file somewhere where you can find it. Now, unzip it. Inside, you'll find a folder called Wheels with all the Gobos placed inside. This is gold. I used to have to go to a website, see if there are any downloads available of the Gobos. I'll right-click and download the icons, hoping that they are JPEGs or PNGs, else I have to convert them, or take screenshots. Man, what a mess. Back to Unreal, I like to stay organized. I'll make a folder called Gobo Demo. I'll now create another folder called Materials. In this folder, another folder called Images. I'm going to copy all the Pointy Gobo images in here and make sure to save all. We have what we need. Let's get into the first technique. Light function materials. Light function materials are special materials you can place into lights. These images work as projections and are extremely simple and effective. Let's go to the Material folder, right-click, Material. Name it M_Gobo MF. MF is short for Material Function. Get your head out of the gutter. Double-click to open it. Under the Materials domain, set it to Light Function. You'll see the input parameters in the Material graph have changed. Hold Ctrl and press Space to bring up the content drawer. I'm going to use this dotty one. Drag and drop it into the graph. Drag it to the pin. For good measure, let's convert the texture into a parameter so we can easily swap out Gobos later. I'll name it Gobo. Save and close. Let's create a material instance of this material by right-clicking on it and choosing Material Instance. I'll name it mi_Gobo1. Moment of truth. Click on the cube with the plus here at the top and bring in a spotlight. Drag it where you can see it. Make it nice and bright. Scroll down to the Details panel and look for the Light Function material. Drag in the material instance we made, and boom! The Gobo is now active. You can adjust the intensity of the light, the color, and even the size of the beam. To change the Gobo easily, open up the material instance and swap it for another Gobo. If you wanted to use a company logo, pop it in here too. Just make sure you made it a perfect square, else your logo will stretch. Yuck. You can fix this with UV manipulation, but that's out of scope of this tutorial. If you want to know how, let me know in the comments. I also like to use my quick DMX spotlights to easily connect the spotlights to the lighting desk for full control. Alright, on to option 2. Parenting a Gobo light to a lighting fixture. Okay, this is hacky, I admit, but it gets the job done if you don't want to dive into more complicated logic yet. I need to patch a DMX fixture and connect it to a lighting console. I use GrandMA.2 as it provides a free universe. If you feel lost, remember I have the Unreal DMX tutorial series. First, let's create a new folder in our Gobo demo folder. Name it Fixtures. Now make sure engine and plugin content is enabled so we can head into Unreal's installation files. Select one of the moving lights in the scene. Make sure it says Moving Head. On your keyboard, hit Ctrl and B. It will take you directly to where this moving head is installed in Unreal's installation. Do not edit this. We want to make a copy of this in our project. Drag and drop it into the fixture folder we made and copy it to here. We will use this fixture for safety. Drag this fixture into the world and position it like this. Back in the Gobo demo folder, create a folder called DMX. In here, right-click, DMX, DMX library. Name it Gobo DMX _lib. Remember the point GDTF we downloaded earlier? We're going to need it. Drag and drop it into the DMX folder. Now open the DMX library. Open the Fixture tab and add a new fixture type. In GDTF source, select the GDTF we just imported. Head to the Fixture Patch tab and patch it as address 1.1 and mode 1. In the next steps, I'm going to speed up the video to keep the video shorter. I'll patch the pointy in the Grandime.2 software, connect the console with Unreal, and connect the lights to the DMX patch we made. As you can see, I have full control over the fixture. Select the fixture in the outliner, scroll down into the components until you see the head. Click on it, add component. Search for Spotlight and add it. Do your best to position this manually to where it works the best. Change the intensity to lumen, intensity to 100, and set the lighting function material as we did before. Voila! The light moves with the moving head. Just make sure not to adjust the dimmer of the light in the actual spotlight or it will wash out the effect. That should already help you in your renders. The rabbit hole does go deeper. What if you want to tie it into the personality? Alright, level 3. I'll be honest, this is the correct way, but also the most painful. If you're building a once-off render, you probably don't need this. If you're building a fixture library, this is probably the way to go. Quick overview. To make a working Gobo system in Unreal, you need two things. A linear texture table that has all the Gobos in order, and a CSV table that tells Unreal how to handle this. If you've played with fixture profiles before, you have seen DMX charts. They lay out how the fixtures respond when they receive DMX through which channels. We are going to harness this. Heading to the Robe website, you can find the DMX chart. Here you can see the Gobo chart. And you can see between which DMX values certain Gobos have to change. We will refer to this again later. Asset-wise, we're already in a great foundation for the next part. Head back to Unreal and select the pointy fixture. Delete the spotlight we added in the components. Look for the Gobo component. Here you will see a Gobo wheel DMX table and two Gobo disk images. If you look in the Gobo chart, there are images. These images must match the images you have in the light and that will be used in the Gobo disk. The Gobo disk will contain the same images we are defining in the CSV. This has to be all set up in a very specific way, else it won't work. Unreal assumes the CSV Gobo slots and Gobo disks are in the same wheel, just represented in two different ways. We will start with the Gobo table. Click on the magnifying glass next to the Gobo table. We don't want to alter the engine content. Copy this into the fixture folder. Add pointy to the prefix so we can identify it. Open the pointy Gobo wheel table. Look closely at the numbers in the table. Look familiar? Looking at the manual, the Gobo slot for the open hole matches the DMX value 0 to 3. This matches our Gobo wheel table. In the very next slot, we already have a mismatch. The manual says the DMX value for the Gobo slot should be between 4 to 9. This chart says 4 to 7. You can also see the Gobo associated with the slot. Let's correct it. I'll refer to the GrandMA.2 to match the correct image for slot 1. We need to do this for all the Gobo parameters. I want to point out here that I count 30 individual elements. 14 Gobos repeated twice, 2 open Gobos. I'll ignore rotations for this example. I'll match these up. I'll speed this up though. Tedious part 1 done. Now the next part, the Gobo disk. I'll use GIMP for this example in the interest of using free tools. I counted 30 Gobos. Each Gobo image is a square and I'm going to compress them to 256 by 256 pixel per Gobo image. The Gobo disk expects a linear texture, so to do this we times 256 pixels by 30 Gobos. So we have a resolution of 7680 by 256. These images can't have transparency. Unreal expects pure black and white for Gobo sampling. In GIMP, I'll align these images next to each other, respecting the Gobo order. If you are confused of the order, you can always refer to the console to get them. We start with the open white, go through each Gobo twice and end up on the open white Gobo again. Export and done. Whew. Import this texture into Unreal. In your fixture, scroll to the Gobo component. In the Gobo component, link the CSV and the Gobo disk we just made. Enter play mode, this is important, and if you did everything correctly, you should now have a working Gobo wheel. Yay! So this is a lot of effort, so only do this if you truly need accurate fixture personalities. The good news is there is a faster way to build fixture libraries once you understand what Unreal expects. In the interest of video length, I'll cover that in a future video. As always, I hope this unlocked something for you. Go imagine, go create, and see if it goes good.